Right, today's notes are again on the properties of rational exponents. So we have the box of the properties there to remind you they are the same as our previous 2 days, but we're also going to add to those properties if m is equal to 1 over n for some integer n greater than 1, properties 3 and 6 can be written using radical notations. So instead of the nth root of the radical a times b, we can pull it apart to be the nth root of a times the nth root of b. Vice versa, we could always smush them together as well. Same thing for the quotient property. You can either pull the radical apart or rewrite it as one radical as long as the root is the same. So we're going to use these properties to help us simplify example A in case we would not have a calculator to use. So the first thing I'm going to do is use the product property. So 4 times 16 gives me 64. So I'm taking the cube root of 64. So if I want to try and simplify this without a calculator, I'm going to go ahead and use my factor trees. So I get 8 times 8, and you can use anything that gets you to 64. I'm then going to break this down to 2 times 4 and 2 times 4 again. And I'm going to break the 4's down to be 2 times 2. So I'm looking at the bottom of my tree. So I'm using these two. This is the bottom of a tree, the 2's over here, and then that 2 all the way to the left. Now the part about this that's a little bit different than what we simplified radicals before is you have to look at the root. This is the third root, which means I'm looking for 3 of the same number instead of 2 like we previously had. So here's 3 of the same number. Here's another set of 3 of the same number, and they multiply together, so 2 times 2 tells us that this simplifies to 4. Go ahead and try the same thing for example B. First, use the quotient property to write it as one radical and simplify. Then, that should get rid of your fraction. Use factor trees. Because you're looking at the 4th root, you will be looking for 4 sets of the same number. Right, and then a little side note at the bottom, for a radical to be in simplest form, you must not only apply the product and quotient properties, but also remove any perfect nth powers other than 1 and rationalize any denominators. So go ahead and try example 1b on your own and then look at the next page. For example 2, it asks us to simplify the expression. So once again, we're going to use our factor trees. I can use any 2 numbers that get me to 54. So I'm going to use 27 and 2, and then I can break down 27 to be 3 times 9, and I can break 9 down to be 3 times 3. So I'm looking at the bottom of my trees, and because this is a cubed root, I'm looking for 3 of the same number. So I have 3 3's, but then notice that we have this 2 left over. So the 3 comes out, but I'm still left with the cubed root of 2. We're going to do the same thing here with example B. 2 numbers that get me 625. I'm going to use 5 and 125. 125 I'm going to break down again to be 5 times 25, and then once again I'm going to break down the 25 to be 5 times 5. So I'm using the bottom of my trees And because this is the fourth power, I'm looking for 4 of the same number. So we have 4 5s, so we know that those are all going to come out. So I'm bringing out a 5. I also have to worry about the variables. I currently have 6 y's, but because this is the fourth root, I'm looking for groups of 4 of the same number. So I can pull out that first group as a single y, and then I'm left with the fourth root of y squared. Try and simplify example 2c on your own. We're going to talk about example 3 in class. So we're going to skip over that and look at example 4. Remember, in order to add or subtract rational expressions, you must simplify each radical term completely. Then add or subtract like radicals, so the same index and the same radicand. So I'm taking the same root and I should have the same number underneath the root. So currently I cannot simplify 4a because the numbers underneath the root are not the same. So I'm going to see if I can simplify the fourth root of 32. So I'm going to use any two numbers that multiply together to get me 32. And I'm going to start my factor trees. And because this is the fourth root, I'm looking for 4 of the same number, which means I do have a 2 left over. So 4 2's come out as a single 2, and I'm left with the fourth root of 2 plus another fourth root of 2. Now my index and radicand are both the same, so I have the same root up top and I have the same number underneath. That means that you can add together the numbers in front of the radicals. So 2 plus 1 gives me 3, and think of the radical as a variable. It just kind of tags along. So this is 3 times the fourth root of 2. Try and simplify example 4b on your own. We will talk about it in class.